Let's review some of our work from class. And we're going to solve for the roots in this problem. And to do that, we're going to be completing the square. So I noticed that we've got x squared plus 4x equals 8. Is this factorable? No, it's not factorable. So we're going to have to complete the square. This, of course, is a, b, and c. We don't have c. We've created a little space. And how do we find c? So we remember that the method to find c, of course, is b divided by 2 squared. So what is b? B is 4, so it's going to be 4 divided by 2 squared. And so 4 divided by 2 is 2. 2 squared is going to give us 4. So c is 4. So we're going to pop 4 on the left side. If we add 4 to one side, we've got to add it to the other. And I know now that if we factor this expression right here, x squared plus 4x plus 4, it's going to simplify to x plus 2 times x plus 2, or simply x plus 2 squared, and we've got x plus 2 squared equals 12. How do we simplify this? Well, we're going to have to take the square root of both sides. And when we take the square root of both sides, on the left side we're left with simply x plus 2 equals square root of 12. And we always ask ourselves, is there a perfect square that we can multiply with another number to give us, in this case, 12? And yeah, we've got 4 in here. So what we're going to do is we're going to simplify the square root of 4 to 2. And we're going to do that at this stage. We're also going to subtract 2 from both sides. If we do it to one side, we got to do it to the other. So now we've got x equals negative 2 plus or minus 2, the square root of 3. All right, and we're looking for our roots. So we've got two answers here. We've got x equals negative 2 plus 2 times the square root of 3, and x equals negative 2 minus 2 times the square root of 3. This is our answer. Let's solve for the roots by completing the square. First thing we need to say to ourselves is this factorable? And it's not. So what we're going to do is we're going to add 18 to both sides. All right. And when we add 18 to both sides, we're going to leave a little bit of space right here because we need to determine what the value of c is. And how do we figure out what c is? Well, c equals what? B divided by 2 squared. And in this case, what's b? B is 7. So it's 7 divided by 2 squared. And 7 times 7 is 49. 2 times 2 is 4. So this is going to be 49 fourths. 49 over 4. And if we add 49 over 4 to one side, then we're going to have to add it to the other. So we're going to have something that looks a little bit like this. We're going to simplify now. And let's do that together. We know that on the left side, we can factor this to x plus 7/2 squared. And on the right side, how do we add 18 plus 49 fourths? Well, what we're going to need to do is, let's sort of shift this over. All right, so we know that 18 is the same as 18 over 1. And if we're adding 18 to 49 fourths, we've got to get the denominators to be the same. And so we're going to multiply both the numerator and the denominator by 4. And so 1 obviously times 4 is 4. And 18 times 4 is 72. We're adding 72 fourths plus 49 fourths. 72 plus 49 is 121. All right. So we've got x plus 7/2 squared equals 121 over 4. To simplify this, what we're going to do is we're going to then have to take the square root of both sides. And if we take the square root of both sides, that leaves us with, on the left side, just x plus 7/2 equals what? 121 is a perfect square, and 4 is a perfect square. And so we can simplify that to plus or minus 11 halves, 11 over 2. All right, and I know that if we're solving for the roots, then we're going to have to get x by itself. We're going to do the inverse operation. We're going to subtract 7/2 from both the left side and the right side. And when we do, that's going to give us what? Well, we're going to have two sets of answers. And so I know that we're going to be, because this is plus 11/2 and minus 11/2, what it's going to look like is, when we subtract 7/2 from both sides, negative 7 plus 11 gives us 4/2, which is 4 over 2 is simply 2. And then when we're subtracting 7/2 from 11 halves, that's going to give us negative 18 over 2, and we can simplify that to negative 9. So this is the other half of the answer. And that's it, ladies and gentlemen. So here we've got another problem where we're going to have to solve for the roots using the completing the square method. And I know that this is not factorable, so we're going to add 12 to both sides. We're going to leave a little bit of space here. How do we figure out what c is? Well, c is b divided by 2 squared. In this case, it's going to be 6. So 6 divided by 2 squared equals 9, right? Because 3 divided by 2 is 3. 3 times 3 is 9. If we add 9 to one side, we're going to have to add it to the other. Great. And so the left side now simplifies to x minus 3 squared. Because remember, it's like x minus b squared equals, well, 12 plus 9 is 21. What we're going to need to do now is take the square root of both sides. And when we do that, the left side simplifies to x minus 3. The right side simplifies to what? You know what, guys? There's no perfect square in the square root of 21, sadly. So when we add 3 to both sides, we're left with this. And this, ladies and gentlemen, is our answer. Let's take a look at one last problem where we're going to be solving for the roots by completing the square. And I see that we've got x squared plus 9x minus 90. This is not factorable. So what we're going to do is we're going to add 90 to the left side to cancel it out. And we're also going to add it to the right side. And when we do, we've got a little bit of real estate here. We need to determine what the value of c is. And we know that c equals b divided by 2 squared. In this case, it's going to be 9 divided by 2 squared. And 9 times 9 is what? 81. 2 times 2 is 4. So this is going to be 81 fourths. So we're going to be adding 81 fourths to the left side. And if we're adding it to the left side, then we've also got to add it to the right side. Amazing. All right, so now what do? We can simplify the left side to x plus 9 halves squared, right? And then on the right side, how does this work? We're going to have to add 90 or 90 over 1 with 81 fourths. We need the denominators to be the same, so we're going to be multiplying 1 times 4, 90 times 4. 90 times 4 gives us 360. Obviously, 1 times 4 gives us 4. And so 360 plus 81 is going to give us 441 over 4. To simplify, what we're going to need to do now is we're going to need to take the square root of both sides. And when we take the square root of both sides, that's going to simplify that to x plus 9 halves equals what? 21 over 2, because 21 is a perfect square. And 21 times 21 gives us 441. And so plus or minus 21 halves. We're solving for the roots. We've got to get x by itself. So we're going to, of course, be doing the inverse operation and subtracting 9 halves from both sides. And when we do that, we've got x equals what? Negative 9 halves plus and minus 21 halves. And so what does that look like? Negative 9 plus 21 gives us 12 halves. 12 halves simplifies to just 6. And then when we're subtracting 21 halves from both sides, negative 9 minus 21 gives us negative 30. Negative 30 divided by 2 gives us negative 15. And that's it, ladies and gentlemen, for these tutorials on completing the squares. Good luck, and let me know if you have any questions.